Welcome to VIGNANAJYOTHI Mathematics YouTube channel. Today I would like to explain probability chapter for 10th class students. So in this probability chapter the subtopic is problems on two dice. Those are rolled at a time or those are rolled one after another at a time. The topic is specified for two dice rolled at a time or rolled one after another. These two cases are gives the same sample space. Okay, shall we move to another slide? The slide is like this. If two dice are rolled, what is the sample space? You know that. What is the sample space? The sample space is like this. See, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You see here all these outcomes are sample space of when two dice are rolled. So therefore, how many outcomes are there? Can you count it? Yes, it is nothing but 6 into 6, 36 outcomes are there. Therefore, if two dice are rolled, then n of s, okay, is equal to 36. So whenever you find a problem on two dice, first of all you have to write down this table under sample space. Thereafter you write down n of s is equal 6 into 6, 36. If you rolled 3 dice at a time, n of s becomes 6 into 6 into 6. Okay, that is 6 to the power of n. Here we rolled 2 dice, that's why n of s is equal 6 square, that is equal 36. Now we will go to solve one problem on these dice. The problem is like this. You see, when two dice are rolled at a time, find probability that getting, so this is the actual event, probability that getting same number on two faces. You have to get same number on two faces. So you have to write down the sample space and n of s for this event. It is nothing but sample space is equal to s, n of s is equal 6 into 6, that is equal 36. Now you have to write down the sample space which has 36 outcomes as soon as fast. This is the actual outcomes. These 36 are the actual outcomes in this sample space. Now here what is the required event? Getting same number on two faces. You have getting same number. You see, among these 36 outcomes, where you can find same number on two faces. Here you can find same number on two faces. Here one face is 1, on second face is 4. Here you cannot get same number on two faces. Suppose if you take like this one, 3, 3, you will get 3 on first face, you will get 3 on second face also. Here you get same number on two faces. Can you identify among these 36 which are suitable to our condition, that is same number on two faces? You see here 1, 1. Is it comes under our condition? Yes. That is, we write down set of favorable outcomes. So what is the first favorable outcome? 1, 1. Can you find same numbers? Here? No. Can you find here? No. Here? No. Here? No. Here? No. So you have to find out throughout this table. You can get these are the favorable outcomes to our event. See, 1, 1 same numbers, 2, 2 same, 3, 3 same, 4, 4 same, 5, 5 same, 6, 6 same. Other than this diagonal, can you find anywhere here or here same numbers? You observe all those things here? No, not getting same number. You have to observe all those things, not getting same number. Therefore, finally, these are our required outcomes. Therefore, you have to keep all these outcomes here, isn't it? See here, 5, 5 and 6, 6 is the last one. So thereafter you have to find out the probability. It is nothing but P of E is equal the formula n of E by n of s. Here P of E means probability of event E. N of E favorable outcomes to E. Number of favorable outcomes to E. Here how many outcomes are favorable to us? 1, 2, 3, 4, 5, 6. These 6 are favorable outcomes. Therefore, n of E is 6, n of s is standard, it is always 36. Therefore 6 by 36 you get 1 by 6. Okay, sometimes you have asked like that, find the probability that getting not same number, you see, not same number on two faces. At that time you will get all those are favorable outcomes. Okay, that time you have to take n of e is equal to 30. That means in that case you have to remove all those 6. Then you will get the favorable outcomes for getting not same number on two faces. That problem also very important in examination point of view. Shall we move to second problem? So the problem is like this. It is common two dice are rolled. Find the probability that getting, here the event is like this. Prime numbers on two faces. In previous slide, getting same number on two faces. Here getting prime numbers on two faces. Okay, write down the sample space and n of s. Then you have to write down the sample space table. Okay, this is the our sample space when two dice are rolled. Therefore here what is the event? You have to write down event. What is the event? Prime numbers on two faces. So where you can find prime numbers on two faces, you see here, you take this 1 comma 2. Here 2 is a prime but 1 is not a prime, so it is not suitable to our event. Suppose if you take 2 comma 3, 2 is a prime number, 3 is also a prime number. Therefore you have two prime numbers on two faces. It is a suitable outcome to our required event. For example, you will take 4 comma 2. Here 4 is not a prime, 2 is a prime, but here we have one prime number on one face. You cannot find the prime number on second face. Therefore this, but our event demands prime numbers on two faces, so it is not suitable to us. Therefore can you identify which are suitable outcomes for our required event that prime numbers on two faces? Can you identify? You see here, all those spinning outcomes gives prime numbers on 2, 3 both are prime, 2, 5 both are prime, 3, 2 both are prime, 3, 3 prime, 3, 5 both prime, 5, 2 both prime, 5, 3 both prime, 5, 5 also both prime. Other than spinning outcomes, can you find any outcome contains two prime numbers? Other than spinning outcomes, you cannot find two prime numbers among these. Okay, therefore you have to write down these here only. Okay, that is 2, 5, then 3, 2, 3, 3, 3, 5, then 5, 2, 5, 3, and last one is 5, 5, isn't it? Therefore here n of e is equal to, count them, 3, 3 plus 3, 6, then 3 plus 3, 9. Therefore favorable outcomes is 9. Therefore it is the formula of probability. Here n of e, not the common things. If two dice are rolled at a time, find the probability that getting. So phrase which is followed by the word getting is our required event. So this is the sum is 9 on two faces. Okay, that write down the sample space and n of s is clearly 36. You will write down the sample space. This is the required sample space for any problem. Whenever we roll two dice, you have to write down this table as a sample space. This sample space contains 36 outcomes. Here the event is sum is 9 on two faces. Can you find which pair gives sum is 9? If you take this one, 2 plus 3, 5, it is not suitable. If you will take 3 plus 5, it is not suitable. You will take 4, 3, 4 plus 3, 7, not suitable. If you take 5 plus 4, 9, yes, it is a suitable outcome. You see many more. Here you see 3 comma 6 gives 9, it is a suitable. Or if you take 6 comma 3, it is a suitable. 6 plus 3, 9. If you take 4 comma 5, it gives 9. Can you identify any more? You see which are our favorable outcomes? You have to observe in this one. You see all the favorable outcomes are bold letters with underline. You see this one, this one, this one, this one. 3 plus 6, 9, 4 plus 5, 9, 5 plus 4, 9, 6 plus 3, 9. Other than these four, can any outcome gives their sum is 5? No, not at all. You see all those outcomes, any one of these outcomes cannot give their sum as 9. Here also you see, here also these any one of these are not gives the sum as 9. Therefore These are the only our favorable outcomes. You have to write down. This is the last one. Therefore, you have to write down the formula, that is n of e by n of s. Here, how many favorable outcomes are? 1, 2, 3, 4. Therefore, n of e is 4, n of s 36. It is nothing but 1 by 9, isn't it? Shall we move to another problem? Yes, here the problem is, what is the probability that first one is the factor of second one? Here, so all these 36 outcomes are in the form of ordered pairs. In this ordered pair, here the condition is first one is factor of second one. So this problem can be asked in another way. The second one is a multiple of first one. Here first one is the factor of second one, or okay, the second one is multiple of first one. These both are gives same solution. Okay, here write down the sample space and write down the n of s, then write down all those outcomes. These are 36 outcomes. Among these, you see, suppose if you take this one, here what is 3? 3 is the first one. Is it a factor of second one? Factor of second one. So this 3 divides the 4? No, not at all. Therefore 3 comma 4 is not suitable outcome. If you take, so for example, 4 comma 2, here the first one is 4, here the second one is 2, here the first one, that 4 divides 2? Not at all, but 2 divides 4. That is the another thing. Here the condition is, the first one divides the second one. Here the first one is 4, okay, and second one is 2. Therefore the 4 should not divide the 2. That's why here 4 comma 2 is also not suitable outcome. For example, you will take, that means what I have, suppose 2 comma 6. Here what is the first one? 2. What is the second one? 6. Here 2 divides 6 or not? Yes. Clearly that 2 divides the 6. That's why 2 comma 6 is our favorable outcome. Isn't? If you take 4 comma 4, here what is the first one? 4. What is the second one? 4. Here the first one 4 does divides the second 4 or not? Exactly, clearly. Here the first one divides the second one. So that's why the first one is factor. Isn't it? Can you identify all those such ordered pairs? Yes, you have see. These are all colored. These are all colored 1, 1, 1, 2, 1, 3. Why? Because 1 is factor to every number. That's why you will get all the outcomes which are having 1 on first phase. But we don't take this one because here 1 is on second phase. But therefore, you write down all these favorable outcomes here. Then count it how many favorable outcomes are there. If you find out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Therefore, 14 by 36, if you cancel by 2 7s, 2 18s, the answer will be 7 by 18. Okay, shall we move to other one? So the problem is like this. Not appear 5 at least on one face. That means you cannot find 5 on any face. That means all the ordered pairs, those who are not contains as 5. First of all, you write down sample space. Thereafter, write down n of s. Thereafter, write down the set of favorable outcomes. So, how can you identify set of favorable outcomes? We can identify set of favorable outcomes from sample space. This is the sample space. So, among these, here you say take 1 comma 2. Is it favorable? Why? Because is it favorable? Is it favorable? Yes, it is favorable. Why? Because this outcome does not contains 5 here and here also. You take 5 comma 6, you have 5 on one face. So this is not favorable outcome. Okay, now what I have identified here, you have to identify here. The easy thing that you have to identify is, first of all, you have to identify, okay, the outcomes which are having 5. You see, all these glowing, all these outcomes, okay, having 5s. Remaining, you see here you can find any 5 among these? Not at all. Here, can you find any 5? No. Here you can find any, here you can find 5? No. Here you can find 5? No. So all these are contains 5 only. Therefore, you have to remove all those things. Then the remaining this part, this part, this part and this part gives our favorable outcomes. Here the favorable outcomes are not this glowing. Other than this glowing are favorable outcomes. Other than these glowing outcomes are our favorable outcomes. Therefore, I have to fly out all these unfavorable outcomes. Okay, I had removed all unfavorable outcomes. Therefore, these are all our favorable outcomes. Let us count how many favorable outcomes are there. After counting all those favorable outcomes, you write down the formula, that is n of e by n of s. N of e's favorable outcomes are 25 by 36. So there is no scope for cancellation. Okay, shall we move to other problem? So the problem is like this. So here condition is the sum on two faces is more than 10. The sum on two faces is more than 10. More than 10 means you will get some may be 11 or some may be 12 or some may be 13. Some may be 13 is possible? Not at all possible. Why? Because the maximum numbers ordered pair is 6, 6. While adding 6, 6, you will get 12 only. So getting some 13 is impossible even while rolling 2 dice. Okay, write down the sample space. Okay, then write down the n of s 6 into 6, 36. Now you can identify whose sum is 11 and whose sum is 12. Those are our favorable outcomes. You see here, sum is 11 or 12 because more than 10 means 11 and 12. 12 is the maximum sum in 2 dice problem. Therefore, can you identify which gives 5 plus 6 gives 11 or 6 plus 5 gives 11 or 6 plus 6 gives 12. Okay, other than these three, can you identify any favorable outcomes? No, you cannot find. You see, all these glowing outcomes are favorable outcomes. Other than these three, can you find any favorable outcome among these? No, not at all. Therefore, you have to write down the favorable outcomes. So therefore, you have to write down the formula and substitute the relevant values. Here n of e is 3, that is 3 by 36. By cancellation, 3 ones and 3 12s. Answer is 1 by 12. Okay, shall we move to another problem? Here, sum on two faces is less than 13. So less than 13 means you may get 1, you may get 2, 3, 4, 5, up to 12, isn't it? Write down the sample space and n of s. Here, which are favorable outcomes? Sum is less than 13 means, you see here, you have to take the outcomes whose sum is 2. You have to take the outcomes whose sum is 3, or you can take the outcomes which sum is 8. You can take the which sum is like that. You have to take all these sums. So here the maximum is 6 plus 6. Therefore 12 is the maximum sum among these 36. Therefore each and every outcome, you say 1 plus 1, it is 2. It is clearly less than 13 or not? Yes, clearly. If you take 4 plus 3, it is 7. It is also strictly less than 13. If you take 6 plus 6, 12, it is also strictly less than 33. Therefore here all the outcomes are favorable to our event. Therefore find the probability. Here n of e also 36, n of s also 36. Therefore 36 by 36, it gives 1. That means whose probability is 1, those events are called sure event. Okay, here getting sum on two faces is less than 13 is a sure event. Shall we move to another problem? So the problem is like this: getting at least one square number on two faces. One square numbers. First of all, you have to remember what are the square numbers. 1, then 4, okay, then 9. These are the 16, 25. These are the square numbers. But which square numbers we can find in the sample space among 36 outcomes? Just you can find two square numbers only. That is 1 and 4. That's all. So you have to square number at least one square number on two faces. Here the phrase most important. At least one. At least one means you may have one square number or you may have two square numbers also. Therefore, here you have to consider the outcomes which are having one square number and which are having two square numbers also. So write down the sample space and n of s, write down all the favorable, write down all the sample space. Okay, now you have to identify where can you find square number. Here you see 1 is square number. So here 1 also square number, 1 also square number. So among these 36 outcomes, can you identify which outcomes having one square number or two square numbers? Let's try to find. So these are the only outcomes having one square number or two square numbers, isn't it? You have to observe all those colored ordered pairs. Watch it. Here 1 is square number, here also 1 is square number, here 4 is square number, here also 4 is square number, here 4 is square number, here 1 is square number. These all colored outcomes are favorable to us. So here you take 3 comma 3. Is it favorable? Why? Because these two are not square numbers, at least one square number. So you take 6 comma 6. This is not our favorable outcome. Why? Because this 6 is not a square number and this 6 is also not square number. Okay, is it clear? To write down the formula, that is n of e by n of s. N of e means number of favorable outcomes. You have to count how many favorable outcomes are there. You have to count, then you have to substitute. The favorable outcomes are 20. If you count all those colored outcomes, got 20, that is 4 5s and 4 9s, that is 5 by 9. Okay, shall we move to another problem? From this slide onwards, I have written only events. Okay, sum is divisible by 4 or the sum is multiple of 4. So these are give same solution. Sum is divisible by 4 or sum is multiple by 4. The numbers which are divisible by 4, the numbers which are divisible by 4 are called multiples of 4, isn't it? Then write down the sample space n of s, write down all the 36 ordered pairs. Okay, then you have to identify which outcomes are suitable towards our event. If you take suppose 1 plus 2, the sum is 3. Is 3 divisible by 4? No. That's why 1 comma 2. This 1 comma 2 is not our favorable outcome. If you take 3 comma 5, its sum is 8. Is it 8 divisible by 4? Yes, exactly. Therefore, this 3 comma 5 is our favorable outcome. If you will take 4 comma 2, what is the sum? 6. Is 6, does 6 divisible by 4? Not at all. Therefore, this 4 comma 2 is not our favorable outcome. If you take 6 plus 6 comma 6, their sum is 12. Does this 12 divisible by 4? Yes. Therefore, this 6 comma 6 is our favorable outcome. Like that, you have to identify which are favorable outcomes, how many favorable outcomes are there. You will take each outcome and then find sum, is it divisible by 4 or not. If not, leave it. If it is divisible, you have to make it as our favorable outcome. Okay, you will try for a while. These blinked outcomes are our favorable outcomes. You see here in first row 1 comma 3, in second row 2 plus 2 4 divisible by 4, 2 plus 6 8 divisible by 4, 3 plus 1 4, 4 is divisible by 4, here comma 5 8 divisible by 4. So all these blinked outcomes are our favorable outcomes. Thereafter you have to write down all the outcomes. So these are our favorable outcomes. Then you have to count how many favorable outcomes are there. Just you have to count 4 plus, here you see in first row 4, in second row 3, third row 2. Therefore 4 plus 3 plus 2, that is 9. Then write down the formula and substitute. N of e is equal to 9. 9 by 36, 9 ones and 9 fours, it gives 1 by 4, isn't it? Then next problem. So getting product on two faces is 12. So if you multiply the two numbers in the ordered pair, you will get 12 are the favorable outcomes, isn't it? Therefore, write down the sample space and n of s. Now write down all those ordered pairs which comes under sample space. Now the condition is product on two faces is 12. For example, you will take 3 comma 5. Here 3 into 5 15 not suitable. Why? Because the product should be 12. Okay, if you take 5 comma 4, 5 4s 20, therefore this 5 comma 4 also not suitable. If you take 4 comma 3, 4 3s are 12. Yes, the product is 12, therefore this 4 comma 3 is our favorable outcome. If you take 2 comma 6 here, 2 into 6, product is 12, therefore this 2 comma 6 also favorable outcome. Or if you take 3 comma 4, 3 4s 12, it is a favorable outcome. If you take 6 comma 3, product is how much? 18. Is it our favorable outcome? Definitely not. Can you try to identify such outcomes? Try for a while. So you see here, can you identify in this table? I had given one animation. So the simple thing is, here I have changed the color for our favorable outcomes. This is the black. Here you have violet. 2 6 3 4 4 3 6 2. These, how many are there? 1 2 3 4. These 4 outcomes are favorable to us. Okay, I have to just change the sign, those who are favorable to us. Thereafter you write down all those 4 favorable outcomes. After you will write down the formula and substitute the relevant values, that is 4 by 36, it gives clearly 1 by 9, isn't it? Then go for next problem. I think it may be last one. Getting even frame on one face only. Here the thing is even frame. How many even frames are there? Can you remember? Yes, exactly. We have only one even frame, that is nothing but 2. That means even frame means 2. That means getting 2 on one face only. One face only. That means you have to find only 1 2. If you have 2 2s, that outcomes is not favorable to us. Why? Because here the word only. Here the word only not allows us to take 2 comma 2 as a favorable outcome. You have to remember that one. You will try here. So this 4 comma 3 is our suitable outcome? No, not at all. Why? Because you don't get 2 here. Here 3 5. Is it favorable? Why? Because you cannot find 2 on 2 comma 4. Is it our suitable outcome? Yes. Why? Because you can find 2 on one face. You take 2 comma 2. Is it our favorable outcomes? It is very dangerous. It is not our favorable outcomes. Why? Because here you have 2 2s. But the problem demands getting even frame on one face only. That's why this outcome not comes. You will try to identify for a while. Now these are, you see, the favorable outcomes are bounced outcomes are, these bounced outcomes are our favorable outcomes. See, so but this 2 comma 2 not bounced, you see. Yes, so other than this 2 comma 2, second row except this one and the second column except this one, all are our favorable outcome. You see, all bounced are our favorable outcomes. Now I will go to write down all the favorable outcomes here only. Okay, so some bones you have missing the shape of the letter. Therefore here the favorable outcomes are 10. Therefore 10 by 36, 2 5s and 2 18s, that is 5 by 18. Shall we move to next slide? This is the most important slide. So here note, I have write down the note 2 comma 2 not comes, because here we can get even frame on 2 faces. Here you will get even frame on 2 faces, but the problem demands on only one face. Okay, therefore thereafter we move to most important slide. You can find some problems, extra problems on this slide, which depends on rolling of 2 dice. So you have to practice all these 9 problems. Okay, to solve all these 9 problems depends on rolling 2 dice. Okay, thank you for watching this video.